Good morning, everyone. When dealing with SURDS, this is the knowledge that we need. We need to know indices from secondary level, where you have the nth root of a to the power m. This can be written as an exponent. An exponent meaning as a power. This a remains the base, okay? And then this n becomes the denominator of a power, and m becomes the numerator. For example, the square root of 3. We know that when there is no power given here, it means that the power is always 1. And when there is no index given here, the index is always 2. So in this case, where there is a, we have 3. Where there is m, we have 1, and where there is n, we have 2. So this can be written as 3 to the power 1 over 2. Let's look at another example. The square root of 6 to the power 2, this can be written as an exponent, okay? So this 6 remains 6, just like this one here, okay? And we have 3. This 3, in this case, it is n. So where there's n, we are putting 3, and this power goes as the numerator of the power, or of this base here. So this becomes 6 to the power 2 over 3. Alright, now how do we use this knowledge? What we are going to do is this. We are going to use it to find the square roots of given figures. Alright, for example, we have the square root of 4. We know that this one can be written as 4 to the power 1 over 2. So what you do, you draw this cross, get this radicand, write it here, and now we use what we call prime numbers. These are numbers which are divisible by 2 and gives a remainder 1, but 2 is also part of them. So we start with the smallest prime number, which is 2. You write it here. 2 into 4, it goes there how many times? 2 times. Can 2 continue going there? Yes. So you put it down here. 2 into 2, it goes there 1 time. Alright, we didn't change anything here. When you multiply 2 times 2, it will still give you 4. So you concentrate now on this part here. Okay, what numbers do you have? We only have 2. So 2, how many 2's are there? There are 1, 2. So you raise 2 to the power 2. And now multiply by what you have here. So you have 2 times 1 over 2. We know that this 2 and this one will cancel. You remain with 2. So 2 is the square root of 4. Okay, let's quickly go to the next one. We have the cube root of 64. How do we get the cube root of 64? We know that this can be written as 64 to the power 1 over 3. Where is 1 coming from? It is the power of 64. Alright, now we get this 64, write it here. Any smallest prime number which can go into 64, we know that it is 2. So 2 into 64, 32, and 2 can continue going there. 2 into 32, 16, 2 into 16, 8, 2 into 8, 4, 2 into 4, 2, 2 into 2, 1. The moment you have 1 here, count the number of 2's. We have 2 here, okay? So we only have 2, then count 1, 2, 3, 4, 5, 6. So you raise this 2 to the power 6 and multiply it by what you have here. So we have 1 over 3, so we're going to have 2 to the power 6 times 1 over 3. So 3 can go into 6 how many times? 2 times. 2 to the power 2 is 4. So 4 is the cube root of 64. Alright, let's go to the last one. Find the square root of 100. We know that here there is an invisible 2 and there is a power 1. So this can be written as 100 to the power 1 over 2. So you get your 100, write it down here. 2 can go into 100, yes. How many times? 50 times. Can 2 continue going there? Yes. 2 into 50, 25. And 2 cannot continue going there, so we change. Can 3 go there? No. But 5 can. So 5 into 25, it goes there 5 times. 5 can continue into 5, 1 time. The moment you have 1, check out. What numbers do you have this side? You have 2 and you also have 5. So you get your 2, write it down here. How many 2's do you have? We have 1, 2. So you write 2 to the power 2 times what you have here. So 2 to the power 2 times this one. This is what we get. And the other one is 5. How many 5s? There are 2. So you say times 5 to the power 2. And now multiply it by the same one, this part here. So when you multiply, you have this 2 cancelling with this one, and this one cancelling with this one. So you remain with 2 times 5. What do you get? 10. Therefore, the square root of 100 is 10. Alright.